Okay, hello everyone. I think it's time to start. My name is Łukasz, I'll be your host today. Welcome to the 25th Scala WAW. It's a special edition. Special because, first of all, we have guests from Lausanne, from Scala Center for the first time. And the second thing is that we're going to have a follow-up meeting tomorrow, which is Scala 3. You should also attend that one. It's going to be very interesting. Our meetup wouldn't be possible with the help of the sponsors, JetBrains, Sumo Logic, who are your hosts today, and iterators. After this short commercial break, the plan for today is first of all we'll have presentation of guys from Scala Center that will tell you about the organization, the mission, and also how you can contribute to Scala. After that, we'll have like a small networking break sponsored by Sumo Logic. There are some surprises on the way as well. After that, we'll have presentation from our veteran speaker, Maciej Gorywoda from JetBrains. Maciej unfortunately got COVID on his way here, so he'll be from his hotel room. To be fine. There will be one more surprise at the end, and after that we'll go to Uwaga Piwo for more beers and more fun. By the way, the beers are over there. Grab some. There's also swag from the sponsors. Yeah. So without further ado, Scala Center, Adrien, Anatolii, and Jamie, and Jędrzej. Welcome.
All right. Thank you, Łukasz, for inviting us, and also thank you, Sumo Logic, for hosting us. So I'm Adrien from the Scala Center. I live in Lausanne in Switzerland. Here is Anatolii, we have Jamie, and Jędrzej here, who lives in Poland. Not far from here, yes. Or maybe a bit far from here, I don't know.
From Oslo.
Okay, so we are going to talk about the Scala Center, but also about contributing to Scala, and we are curious also about you. So we'd like to chat with you maybe after the presentation or later today. All right, let's go. So in this image, you can see those beautiful stairs that inspired the Scala logo. So those stairs are located in EPFL, where Scala was created. And I think this picture was taken in Scala Days 2019. Yeah. During a spree. So a spree is some events that we organize where people can come to contribute to open source in Scala, because we are Scala Center. And we will do one tomorrow. We'll talk later about it. Okay, so let's go. I try to not be too long on the introduction, because we have a lot of things to show you, more concrete things to show you later. But basically the program for today is to talk a bit about the history of Scala, then what the Scala Center mission here, then we will present the ongoing projects at the Scala Center, and then how you can help us and contribute to Scala. Okay, maybe some question before to know more about you. Who is contributing to Scala? Like to open source Scala from the audience? I'm sure some people do. Okay. 3? Yeah, basically. Okay. One thing is, if you go to a Scala meetup, that's also a way to contribute because you share ideas about like programming with other Scala developers. That's something that share excitement and everything. So I think if you are here today, it's because you are all like in some way Scala contributors. History about Scala. Oops, that's bad. Okay. It's probably not the only occurrence of it in this presentation, but okay. So Scala is at first a research project started by Professor Martin Odersky at the laboratory LAMP, which means Laboratory of Programming Methods. It started in 2001, so it's a bit old. So basically, Scala is more than 20 years old now. And then sometimes after that, it becomes open source. So at the very beginning, it was just some research project, and it becomes open source 3 years later. And then people in the programming community noticed this language and started to build an ecosystem around it. So with tooling like SBT and also libraries and web frameworks, those kind of things. And then later, the industry used it as well because they saw some value in Scala. So there is this famous blog post by Twitter engineers back in 2009. They decided to use Scala because they wanted the code to be correct and also maintainable. And that was not enough. They also wanted to use a language that they are passionate about. And I think this is still true today. So of course we need to write correct code and maintainable code, and Scala is really good to do that. But also a lot of people from the community are quite passionate about Scala and about programming in general. Okay, what about Scala now? So 20 years later, Scala is still a research project and a productive one. So in 2015 we got Scala.js, so from LAMP at EPFL, then Scala Native in 2017, and then last year we got Scala 3, but it's not the end. Martin has not yet retired, and I think he hired like 4 new PhD students this year. So there are new things coming. So we have new research publications about Scala, and also we have like new experimental features in Scala 3. So currently it's 7 of them. I only printed like 5 of them. So explicit nulls, cipher exceptions, capture checking. So capture checking is I think the big next thing. They are working hard on it. If you don't know what capture checking is, you can check out Martin's keynote from ScalaCon this year, which is
Scala
called...
IO.
Sorry?
And Scala.io.
Yeah, but it's... yeah, maybe it's... okay. I'm not sure if it's available, but it will be available. And the talk is called simply Scala. And there is... So Martin is quite excited about it, and recently he tried to use capture checking in the compiler itself. So there is this PR, I think it got merged yesterday, to try the capture checking in the compiler itself to track like the context and to bring some performance in the compiler itself. Then we have fewer braces and name type arguments. What about open source? So this is a chart of all the open source libraries in GitHub from 2013, like from Scala to 10. And as we can see, the number is still growing. So we have about 8,000 open source projects on GitHub for Scala now. And the migration to Scala 3 has started. So it's growing slowly. That's about 2, how do you say that, billion?
Yeah, 2 billion, yeah.
Yeah, 2 billion lines of code and more than 20,000 contributors. Okay, what about the industry? So we are not quite sure about the number. It's really hard to know the precise number of the companies using Scala, because Scala is all open source. But we think there are about 1,000 of companies using Scala. One thing we are more confident about is the number of Scala developers, because we have the numbers from our like education platform, like Coursera. So we think there is about like 1 million Scala developers worldwide, and In 2022, from the Stack Overflow Developer Survey, we can see that Scala is like one of the best paid programming language. So here are a few examples of companies using Scala as one of their main programming language. All right, so this is it. Scala, a research project, an open source ecosystem, and an industry behind it. And at some point, we needed also a central organization to organize everything around Scala, and that's the Scala Center. Okay, so we are open source, we are for education, and we are not for profit. So basically, we are the open source education for Scala. Scala Center was created in 2016 at EPFL. We are not for profit. So all that we do, we try to do for everyone in the community, not only for one company or not for one stack or those kind of things. We are 12 people in the team currently, and we are growing. So yeah, I should add maybe 2 more heads here. So the team is composed of some administration people. We have also some communication people, and most of us are engineers. At least we are, the 4 of us, yes. Yeah, maybe you're also more on communication now, but also an engineer. And we are backed by an advisory board of 10 companies and 2 community representatives. So companies are here to guide us, to bring us feedback on what could be improved, and then we decide also with the community what is important to work on in the Scala ecosystem. Right, so what is the next challenges for Scala? Jamie.
Okay. So I'm Jamie. So I want to talk about basically what is happening in sort of 2021 and 2022. There's kind of a perception out there in the industry that Scala is too complicated to learn, and it's hard to train new engineers, and how do you get started with Scala? So what we've been working on this year is really trying to improve the onboarding experience for the new engineers, so that you go from knowing nothing to being like a superhero. So we're basically breaking that down into 4 areas this year. So how do we improve how to train engineers? How do we improve simplifying everyday tasks for the developer? And how to strengthen links in the community? And how to ensure that Scala remains a sustainable language for the future going ahead. So taking a look at training engineers, Scala Center was basically founded originally to produce MOOCs, known as like massively online courses. So we have a number of courses on Coursera, which are for free, or you can purchase a certificate for proof that you completed the course. And also we are offering the Extension School program at EPFL, which gives you for one-to-one support with one of us for a larger price. But yeah, it's really helping us to fund the effort that we go on. We also are producing YouTube videos. So you see under the sort of playlist, Let's Talk About Scala 3 on 47 Degrees channel, but it's now being renamed to Zebia Functional. So we're basically providing videos to teach you how to use the debugger that's coming up, how to use Scala.js, and sort of how to think about data structures, things like that. And also we're trying to really improve the experience from when you first get onto the website. So what I can say about this is basically the Scala website hasn't really changed too much since 2012, and also it's sort of grown very organically, where we have many different kinds of tutorials and guides, and the information is very spread around. So eventual long-term goal is to try and reconsolidate pieces so that it's easier to navigate and use. So we want to redesign the front page. We kind of already did that by making it a lot smaller. And yeah, this year we focused a lot on improving the getting started experience. So now there's only one way to install Scala, or the default way to install Scala is just to use this one tool, Corsair. And basically there's a one-liner that you can copy and paste into your terminal. And we have sort of more guides for what to do if you come from Java. We improved that guide, and then also we produced a guide on how to start contributing to open source software, which you can find. How do I go to the tab? Sorry, I don't know.
Yeah.
Okay.
Scala
Docs.
Scala link.
Yeah. So yeah, if you come down here, then you see how to get started with open source, and then there's sort of FAQ that you can read. And then here's what I was saying about the getting started. So you can pick based on your platform, you get a different command. And then how to get started with Java. Yeah. Thanks. Oh no. Okay. Yeah, and then finally we also been trying to convert the documentation so that it reads better based on your choice. So either you can see it from the Scala 3 perspective and it teaches you how to do things with Scala 3, or the same with Scala 2, and mostly it's the same for both, but we just changed the syntax to update it. But yeah, so the entire tour of Scala is now sort of unified between either 2 or 3. And basically, cool thing. Okay. Yeah, so if you're in, for example, the tour of Scala and then go to basics, then you can see like, oh yeah, most of the things are the same. Or when there's a difference, then you can see that either the Scala 3, or when you click Scala 2, then everything becomes Scala 2. Okay, so yeah, one way you can contribute is to help us sort of migrate the website to use this. Yeah, so to summarize, the goal of the documentation changes is to provide the clear path for the complete beginner to become confident in programming with Scala, to make it easier to train engineers, and we want in the future to basically put on the front page more of the use cases that you can use Scala for to actually do things with, rather than just say the fancy features that exist in the language. Yeah, and we also want to show that Scala is simple to use, or that there are ways to write Scala in a simple way, so that we can improve the confidence of companies to adopt Scala more. Yeah, so if you want to help, basically you can find pages that have code examples on them that haven't been migrated to use these tabs, and then you can submit a pull request to update to use that. Yeah, and if you care, then the GitHub repository is scala/docs.scala-line. Okay, and now I'll pass over to Adrien again.
Yeah. Okay. Okay, so simplifying everyday tasks. So that's about tooling mostly. So we are a team of engineers, and we try to improve the state of the tooling in the Scala ecosystem to make it more easy to use for everyone. So metals, like the IDE for Scala in VS Code, was started at the Scala Center. We also worked on Scala format, Scala fix, Bloop, which is a compile server for Scala, and ScalaT, the online code editor for Scala. And also we contribute to other tools like SBT or Corsair that were created by the community, but are very important assets of the tooling ecosystem. So I won't describe all those tools now. We will just give some demos of recent and cool improvements in ScalaWAW and then in the debugger in Metals. Yep, so ScalaWAW. Whoops, sorry. ScalaWAW, right here.
Okay, so I've joined Scala Center 5 months ago, and from that time I started figuring out how to add metals to ScalaWAW. And I've managed to do it. We can now have completion. Sorry, I'm very... the keyboard is different. It's Azerty, not QWERTY, so it will take me some time. Yeah. So it's import, STTP, everything works. Libraries are also supported. And for now,
Very good choice of a language.
maybe you should type because it's too hard for me. I didn't think about that part. Yeah. Basically, right now, which are supported, and hovers. In the future, I plan to add signature helps. So whenever you open a parenthesis for the method, you will get the fields it requires for apply. And also many others, like go to definition, view references, maybe even refactor. Mostly all stuff that Metals have, but it requires UI changes.
To show how to debug. Okay, let's play this. Okay. All right, so we recently added a lot of new features in the Metals debugger. So the Metals debugger was until now it was basically a Java debugger on a Scala class path. So there was no like things such as expression evaluation, or you would see all the internals of the generated methods by the Scala compiler and everything. So we are working on it to make it very more Scala-like. So one thing you can do now is to, let's try to put some simple breakpoint here. So I'm going to create a node, node 1, create node. Okay, so that one thing that we have now is expression evaluation. So I can, for instance, repository dot, I don't know what I want to do. Let's say create node of node 2 and empty content. What?
You're gonna recurse on the...
No.
Okay.
So now if I reload, yeah, I have a node 2. So yeah, just using plain Scala syntax in the debug console. This is not like a fake expression evaluator. We really use the compiler inside. So we have also support for things such as implicit resolutions. So here, what do I have? I have a node. Yeah, so here, for instance, I can translate a Scala object of type node to a string using, I think, upickle. So to do that, I need some implicit of type writer, but since it's Scala, the implicit is provided automatically by the context. Yep, so now I was able to translate my node into JSON. Also, it supports like macro expansions. So I created this macro here to show the Scala type of something. So I can show the Scala type of node, and it prints node. So this expression evaluator, it works pretty well on Scala 3. I still need to work on it on Scala 2 to make it better. Also, we have now support for conditional breakpoints. So here I have a breakpoint that only stops if the title of the node that I want to delete contains debug. So I can try that. Let's create a node with debug.
To start.
Oh no, it's multi-threaded. Yeah, so I can stop as many threads as I want. So here I have one thread that's paused on saving one node. I can resume it. Okay, so now if I delete a node that does not contain debug, it should not stop. If I delete one that contains debug, it stops. We also have like log points. So edit breakpoint, log message. What should I? Creating nodes, and then so it's Scala syntax. You can put interpolation title. Yeah. Good. Then create debug again, and now it prints it. So you should, using this debugger, you should not need to add println in your code. You can use these log points. One thing that we did as well that is kind of transparent, I mean, you won't see it, is a step filter. Is it here? Yes. So breakpoint again, create node. So what is the step filter? Oops, sorry, what's happening? I don't know. The step filter is that the debugger won't stop on generated methods by the compiler. So here I want to go into save note, and save note is an abstract method. It's not implemented in this repository. So Scala would use like things such as mixing forwarders to forward this call to the class implementing it. But here, if I step into, I go directly in the implementation, so I won't see those intermediate steps. That is, this create node methods and this one. No, this one and this one. Yes, that we call the mixing forwarders. So maybe it's all a bit obscure, but that's the point. We don't want to show you obscure things about Scala. We want to show you what you should care about, which is your code. So now the next thing we are going to work on is to print a better call stack. So we will be able to print the real Scala signature of the methods and not the one from the class files. And okay, there are more things I could show you on the debugger, but I will soon publish a video on YouTube to explain everything, so you will be able to learn more. Yep, that's it for the debugger. Your presentation. Okay, ScalaDex. So ScalaDex is the who is using ScalaDex? Not so many people. Okay. So ScalaDex is the website that indexes all Scala libraries from GitHub, basically. And we are trying to make it better. So, for instance, we want to make it better for people to find libraries based on their version of the language or based on their platform. So if you use ScalaJS, you can filter on ScalaJS and then also on Scala 3. Then if you want to find like a library which is available, why is it slow? Okay, it's slow. Damn. So. Okay, then if you want to find the version that is compatible with Scala 3 maybe, you can click here and the server is slow. And then you can see like we have 4 versions available to run cats with Scala 3. We also, in ScalaX, we also have this awesome Scala that shows all that you can do using Scala. So for distributed computing or functional programming, of course, command line pathing, and you can also filter on your version of Scala, your version of the platform, and your version of Scala. So what's available on Scala 3 and maybe ScalaJS, and this is what you can use today. Okay, so that's it for libraries. The big next project that we are working on also with Virtuoslab here in Poland is the Scala Toolkit. So it was already announced by Martin and Christoph, and there is a blog post about it on Virtuoslab blog. Okay, sorry, Christoph from Virtuoslab, who is the lead of the Scala team at Virtuoslab. The goal of this toolkit is to provide a set of libraries that are good for scripting. because currently there is a focus. We think from the community there is a focus on libraries that are very powerful, like very extensible, but that are not so easy to begin with or to use for solving simple problems like a script. So I don't know, sending a request, scraping some HTML and find some information and automating those kind of things. So we are trying to work on it, not by creating new libraries, but by collaborating with the community to promote more the simple libraries that we already have. So we want to provide some guarantees, like it should be compatible with Scala 3, ScalaJS, and also Scala Native. And we will focus on discoverability, so to make it easy for people to use that library if they don't know it. Overpower and oops, sorry, that's not what I want to say. Overpower and flexibility. And also we want to provide some cookbook on how to use that toolkit for solving everyday problems. So it could look like something like this. So using the new Scala CLI tool, we can simply import the toolkit like this, and then we have HTTP to send some request and JSON to parse this request, and then maybe we can call a function that, so this function needs to be written, but you can call a function that show what the response is. And because it's a toolkit, it's you can run it with JVM, but you can also package it as a JS script and then run it in your browser to print some chart or whatever you want. So yes, next year you should hear more about that project. All right, so next thing is language sustainability.
So hello everyone, my name is Anatolii, and I'm going to let you know a little bit about our community and language sustainability projects. So as was already discussed, and probably the red thread through the entire presentation is that Scala relies very much on the community, on the industry partners, on the community, and on the research. We are not like some of the programming languages that have big corporations that is backing them with a lot of money, and therefore having a lot of better say into where it is going to move and how it is going to move and who is going to do the features. So we are more at the intersection of the community, industry, and research, and therefore the language sustainability and language survivability and language thriving, it greatly depends on connecting the dots. So making the community people, the industry people, and the research people interact one with another, communicate clearly about each other's needs, and being able to collaborate effectively together. So this is where we are going with the language sustainability projects. The first one is so-called Compiler Academy. So the problem that we are trying to solve is making sure that the language is robust and doesn't break under you when you're using it. And here you can see a graph of dirty issues per month of 2021, and you see that the graph is constantly on the rise. So in blue you see the opened issues, in red you see closed issues, and in yellow you see the cumulative increase of the issues, and you see that it's increasing fairly steadily over the time. So at Scala Center it's something that we are actively thinking about to first of all make sense of the issues, because not all of the issues have the equal impact. Some of the issues might be blocking some critical project from migration to Scala 3. And some of the issues, they are some very corner cases in the type inference logics that do not need to be immediately addressed. So we need to allocate our limited resources with the greatest impact. Well, one of the directions, these are the summary of the problems that we are facing. Which is, besides the number of issues on the rise that I mentioned already, is the little number of core contributors compared to other languages. and also no formal process in place to gain contributors. At least that was the situation at the middle of 2021, where the project was originated, the Compiler Academy project. Well, now we have this formal process in place, and this is exactly the Compiler Academy. So what is it? It's an effort by Scala Center to bring community into language sustainability, into the compiler, basically, into contributions to the compiler. Because we know that the community of Scala, it has a lot of talented people who are very interested in type theory, in how the compiler works, in how it does the magic behind the scenes. Because, I mean, Scala is a complicated language, and so it attracts people who are attracted to complexity. So there are a lot of enthusiasts that are interested in the compiler inner workings. So we are bringing them in with this Compiler Academy project. And what is it? It is a pair programming event that consists of small teams that meet together regularly online over Zoom, more or less once every month, once every 3 weeks, to work together on the Scala 3 issues and exchange the experience. There is usually one mentor and 1 to 3 mentees per team. That was the model that we were working with during the past months, but now it is set to change because we are making it more open to the community. So that means that it is now running on Discord, on the public Scala Discord. So everyone who is interested in Scala, who is on the Scala Discord server, which is also published on the Scala website, on the Scala documentation website in the community section, or you can Google for Scala Discord and you will find it easily. There is a channel for contributors, for Scala contributors, and there we have the announcements of the upcoming Compiler Academy events, which, as I said, are regular, once every 3 weeks. And you can just drop in and get to interact with other people from who are also passionate about the compiler. Since summer 2021, when it originated, which is more than 1.5 years ago already, around that, we had, this is a mistake on this slide, it's not 21 iterations, it's 23 iterations already. And during those 21 iterations, we made a lot of incremental progress. So it started as an internal event for a Scala 3 core team only, and then it became more open to people from as a community, but closed medium, our closed Slack. And then now it's in the autumn of 2022, it became open to the community invite, so it's on the public Discord server. Besides that, under the umbrella of the Compiler Academy, we have another effort, which is a YouTube channel. So what is it all about? Well, compiler is a complicated beast, of course. It's difficult to get started. And there is a problem that you need some information about the inner workings and about the areas that you want to contribute to. And now that we are increasing the number of people, that we are trying to bring more people from the community to contribute to the Dota compiler, we cannot scale the amount of mentors that we have available together with the number of people who come. And this means that we need to allocate the mentor's time and to use it more productively. And this is why we have created the YouTube channel. And the YouTube channel is essentially talks by the core members of the Scala 3 team, who actually wrote the compiler and know the best about it, to talk about getting them to talk about how it works internally, about their specific areas. So, for instance, Nicolas Tuki, who authored the macros, he made a video about the metaprogramming implementation in Scala 3 that you can see on the slide at the left. And it's a 1 hour and 44 minutes thorough walkthrough through this area of the compiler. In the description, there is a link to GitHub, to the issue tracker, with the filtered issues of metaprogramming. So if you're enthusiastic into learning more about how this synth works, about how the modern compilers work, you can watch this video. You can go to the issue tracker, and that can be one of your first issues at the spree. And when you come to the spree event, to the compiler spree event, you get to interact with like-minded people who came to learn, who came to exchange experience, and you can hack on the compiler together for 2 hours. And afterwards, you have the Scala contributors channel where you can ask questions, and there are people from the core team also present at the channel to answer those questions. So the bottom line is, if you want to contribute to the compiler, you have a roadmap to do that. You have the Compiler Academy where you can get to interact with the common-minded people and the core team people and get ahead in this task. Here is a little bit of the statistics about the Compiler Academy YouTube channel. The spikes on the graph is when we publish new videos. And it might seem like not too much for YouTube, just 3.4 thousand views in total and 203 hours of total watch time. And the stats are outdated by a couple of months. But when you remember that this is a highly specialized content about the modern programming language compiler, then it's pretty amazing that people watched 203 hours of this content. So it's really slowly but steadily picking up speed, and we are getting some traction with the community. Moving on about less challenging topics than contributing to the compiler itself. Also closely related to these topics, it's the Scala improvement process. So it's about making decisions about what new features Scala needs to get in the future, about what changes to the language needs to be made, about prioritizing the work that is done. The Scala improvement process is a way for the community to get to interact with the core team, the community and the industry partners, to interact with the core team and to deliver it the information about its needs and what course needs to be taken. It consists of, Scala improvement process is just as it sounds, it's a highly formalized process where people who are on the Scala, on the SIP committee, they get to review the proposals from the community and get back to the people from the community with the feedback of the committee, and it is a collective decision-making story about how to get the opinions of the community counted when deciding about the future of the language.
Yeah, I just also wanted to say, if you go back, anyone can propose a SIP, and you do that by first going on the Scala contributors forum, which is, you could search that up on our website. But yeah, basically if you make a topic called pre-SIP, you can basically propose an idea, and if people are kind of behind you, then you can copy the template for to make a formal proposal. And then every month there's votes from the committee.
Mm-hmm. Yeah, and obviously all this process is also written out on the Scala website in the documentation. So you can look it up, and you will see the instructions of how exactly you can submit a new proposal to the language. And so that's something that we had for the Scala 2, and so that's something that we only recently ported to Scala 3. And we already have 2 SIP proposals accepted and voted on and accepted. So one of them is clause interleaving, that allows you to have type parameter clauses in between ordinary parameter clauses. That can be useful for to provide types that depend on the input of the previous argument clause, and then, for example, do an implicit lookup on those types. Another one is the polymorphic AT expansions. So as you can see, it allows you to be to have the polymorphic functions applied to implement polymorphic functions that maybe Jamie would be best to explain that because he knows that better.
Yeah, so in Scala 3, there's, if you have any tuple, there's a method called map, which basically allows you to apply a function to each element. But it's kind of generic, so it works on, it doesn't care what the type of the element is. So that's why it has this funny T here, which basically means, yeah, it's a function that works on any kind of value. But previously you had to write it like this, so you can't just pass option apply, for example. So now with this function, if the SIP is implemented, then you'll be able to just write option apply instead of putting all this boilerplate. There we go.
That is to make the point that the process is implemented and the first several iterations has been made that resulted in certain decisions to the core language. So that was part about the language sustainability, and another thing that is closely related to the language sustainability is the community part. Because as we said previously, that Scala development relies heavily on building bridges between all the parties that go into the community around Scala. So one of the things that we do to help facilitate this building bridges thing between all the parties is, of course, conferences and meetups that you come to listen to other people's experience and also to interact one with another. We had ScalaCon that recently was organized in October, and in the next year we are going to organize Scala Days, another iteration, which will be announced separately. Another thing is, I guess, again for Jamie.
Okay. Yes, so you may have noticed it's December. And if you didn't know, there's this cool challenge which is run like not by us, by another organization called Advent of Code. And it's basically throughout the month of December, there's a fun challenge for you to solve every day. And so we set up a website last year, and we're continuing this year, which is basically a collaborative effort of the Scala community to submit your solutions if you solve it, and also we're providing our own input and sort of explanations of how we solve the solution. Yeah. So, yeah, for example, if you go to day 6.
Day 6, yeah, sorry.
Yeah, so today is the 6th of January, and we've written the article for how to solve today, but maybe this is spoilers for people if you care.
You can run it.
Yeah, we also have a solver which runs with Scala.js, so we compile the solution to JavaScript, put it in the web page, and you can paste your input and get the answer if you want to cheat. But yeah, the point is anyone can edit the page and link their solution if they want to do that. So that can be something fun for you to do, to contribute, share your solutions. And we have a Discord channel in the Scala Discord server called Advent of Code. It's promoted really heavily in the first section. I don't know if you have it open.
No.
Okay. Okay, and yeah, so yeah, every day we're publishing the current puzzle solution. So yeah, we would like you to, if you want to take part, join the Discord, join in discussions, and add your solution if you want.
So Scala Spring is the next thing that we do, and that we, as a matter of fact, are going to do tomorrow here in Warsaw. at the offices of Sunrise. That probably you also got the announcement about. So what is Scala Sprees? It's an event where we, Scala Center, organize on-site at various places, at various Scala communities that we go to. For instance, recently we went to Paris to organize that event and co-locate it with the Scala I/O conference. And this time we are collocating it with our Scala Warsaw meetup. So what is it? It's basically an effort to help people who want to contribute to open source, to get them started contributing to open source, contributing to the open source Scala libraries. It's a hackathon event where people who want to contribute, they come on site, and there are mentors there. The mentors are the authors of the open source projects that would like to welcome contributions to those open source projects. And the idea is that the would-be contributors, the people who would like to contribute, they spend a couple of hours hacking on the good first issues, and if they have any questions about the project, about the procedure, how to contribute, they have the mentors that they can ask. So that event is going to happen tomorrow, and also you have a chance to win a t-shirt, a special t-shirt of a Scala contributor that is reserved for people who got their PR submitted and merged to a Scala open source project. So if you would like that magic t-shirt, you're welcome to come tomorrow and try your luck in
Please
this.
come. It'll be fun. You get cool t-shirt.
Yep. And yeah, so now a little bit of summary. We gave a lot of information in this presentation about various directions that we do. So the red lines through all of this information is that we would like to interact more with the community, and we would like the community to be involved more in the language development and with the development of the community. And how, being a community member, what can you do to contribute to Scala? What is the summary? Well, if you are a company that has a Scala team with it, that's your chance to train new Scala developers, which would include finding new talents, bringing diversity, and nurturing and fostering your own culture. If you are a Scala programmer or a company, you have an opportunity to invest your time or money in the supporting open source projects. So if you are a programmer, it's more about time. Come to the spree, to the contributors spree, or join the compiler academy, or just look at the libraries that you use every day and like using, and try fixing one of the issues there. If you're a company, what you can do is see if you can dedicate, if you can give your engineers maybe 10% of time, for example, to work on open source, which some companies do. Also meetups and conferences. First of all, coming to a meetup is already a contribution to a Scala ecosystem, because you get to interact with other community members, you get to exchange ideas. So somebody will be inspired by what you say, you might be inspired by what others say. And finally, another thing is if you're a company, join the advisory board of the Scala Center, which is basically a set of companies that sponsor us. We are a non-profit, as we mentioned before, so the way we work is, well, most of our revenue that sustains us, it comes from, in part from MOOCs mostly, and also in part from the advisory board members, that is the companies that have Scala departments in their team. And they would like to support the Scala Center in the efforts that we have just mentioned to you in this presentation. So if you like what we are doing, if your company relies on what we are doing, then it's a good idea to consider joining the advisory board to invest in the future of Scala and guide the community and support us. Here is a continuation of the previous slide with some concrete things that you might want to do to contribute to Scala. First is training new developers. It's mostly about MOOCs. If you're a company and you would like to grow new Scala talent, consider pointing them to Coursera courses, which are free. But there is also a paid tier for the certificate. And also the top tier is EPFL Extension School, which is essentially the same material as on Coursera, but with the possibility to get one-on-one mentorships with Scala Center people. Meetups and conferences, you can find them on Meetup website, or if there is none in your city, create one. Supporting open source, that's what we already mentioned. It's about Scala decks. Go to Scala decks, see what cool libraries are there, what you're using, and see if anyone needs some help with the issues. Compiler Academy and SIP, that goes the same direction. If you want to get into the compiler, go to the Discord, find Scala contributors channel and stick with it, watch for announcements. SIP is if you have some cool ideas about how the language should develop in the future, some cool new feature, for example, submit a SIP proposal, a pre-SIP proposal. And joining the advisory board, that's just that. Not much to add there. Reach out to Scala Center and find out how to do that. And thank you for being here. Thank you for your interest in Scala, for coming here today to network, to listen to how all the pieces of the puzzle come together. And thank you for your interest in Scala. So, do you have any questions about what we presented today?
Too much.
I just wanted to say that if you want to join the Scala Discord, you can go to the Scala website and find it here, and I'll try and make a QR code now. What? If you want to join the Discord, go to discord.com/invite/Scala, I guess.
Okay, some questions, please. Do you use Scala 3 at work? Why?
That's actually a question I wanted to ask. Do you know anything about the adoption of Scala 3?
What do I think about the? What do we think about?
Do you know anything about the adoption of Scala 3 in companies on production? Okay.
It's hard to answer. I'd like to ask the same question to you. So I don't know.
That's the reason we
I hope that works.
are
If you want to
outreaching
join
to the community to gather feedback about how the adoption is going, what is maybe blocking, what is cool about it. So that's one of the purposes for doing these things, these meetups.
So have you ever heard that someone is actually using the Scala 3 project?
Well,
So far?
we heard the stories of migrations. Like, for instance, I was recently speaking to the people from Disney that are considering doing it. It's moving. It's not migrated, but they are considering it. So that's my personal experience from interacting with the companies.
So what's the biggest problem for them to adopt?
So the biggest one so far that they quote is LinkedIn. So the language itself is surprisingly stable, and which maybe was not the case half a year ago. We felt more flimsy feature-wise, but now it's like the language is not the problem, and the problem is more about LinkedIn, which is to have the machine tell you where, for example, you have unused variable in your code that you might want to remove, or where you have in a functional code, if you have, for example, seen a statement that you forgot to include in the monadic flow and return from it, so this kind of things.
Yeah, I remember also the macro annotations was a big thing for Spotify, for instance. So they are waiting on the new implementation of the macro annotation, which is coming, but we don't know yet when to migrate. So those small things that were available but experimental in Scala 2, and that now people need to migrate to Scala 3. No more questions.
How many people have used Scala for less than 1 year? Okay. Oh, phew. 2. Okay. More than 2 years. Oh wait, okay, more than 2 years. Okay.
Not a lot.
Less than 2 years? Okay. Between 1 and 2 years. Okay. Okay, there's a lot of range people. Here's a good one. What was the best way you learned Scala? If anyone wants to volunteer.
Martin Udarsky's book.
Okay. Is that the functional programming?
Yeah.
Okay.
Also the Prog Fund on Coursera years ago.
Mm-hmm. Okay.
That was a big thing.
It's still available, and it's on Scala 3 now.
Does anyone use the Scala documentation website?
Yeah, I do.
Okay. If you don't use it, then what do you do when you need to know something?
What? GitHub.
Okay. Go to the sources. Okay. Okay.
What's your biggest pain with Scala?
Yeah, it's a good one.
Was the pain?
Yeah.
Finding talent pool.
Compilation time.
Compilation times. Yeah. What version of Scala are you using?
2.13.
Okay, and what build tool?
Gradle.
That's maybe why. But do you do Gradle use Zinc to have incremental
Sorry?
compilation? I'm not sure that Gradle use Zinc, the incremental compiler.
Oh, I'm a little bit short on details, but we are using like Gradle Enterprise and we cache everything heavily. So I'm not exactly sure about on the incremental compilation stuff.
Okay. Yeah, that was a big thing in SBT. People were complaining about compilation speed, and then then Zinc got better. So it's still slow, but we don't recompile all files, so it's acceptable.
Have anyone tried learning Scala 3?
Three?
3 people tried learning Scala 3?
Is it different from Scala 2?
Well, I mean new features, as in what I mean by learning Scala 3 is like looking at what new is available and seeing how you can do your projects with it.
How many people don't use Scala? How many people use Scala outside of work?
Outside of work.
Yeah. Okay. Okay.
But
8?
that doesn't mean we don't use it at work.
Yeah. I mean, okay. Yeah. How many people use it in work? How many people don't use Scala at all? Oh wow. Okay. Nice. Oh, nice. Okay.
How many people would wish Scala 3 got adopted at their workplace? How many people wish that Scala 3 would be adopted at their workplace?
Okay.
Why?
Yeah, what is the most exciting feature that you would like to use at the workplace?
No curly braces.
No curly braces,
Yes.
yeah.
Okay.
It's better to have one language than two. Because saying that those are so similar is not true, I would say.
Scala 2 and Scala 3? Why?
I mean, I haven't used Scala 3 in production, but I've been using Scala 2 for almost 10 years. So I'm now looking at Scala 3 code, and this is like very different. Like you used to different classes, etc. Now just define a trait and then extension methods and stuff like that. This is like totally different. So when do you define methods? When do you define functions? And when do you define extensions?
Yeah.
And you have like lots of options, right? If you have one code base only Scala 3, then the question will disappear automatically, right? But if they will look at both code bases, they will be like, what should they do?
People will have to read Scala 2 code for years, for a decade. So if they learn Scala 3, they need to learn 2 different languages basically.
Well, I mean, extension methods-wise, it's can be argued that Scala 2 is the same story, because what essentially extension methods is the type classes.
Yeah, no, but this is like you talking as an expert, right? How it's expert.
You are an expert.
You are the expert. So
the
it's
expert.
like obvious. You have this problem of being like trapped into being like expert in some kind of matter, and then it's hard to actually put into the shoes of a newbie. Right?
Would you?
Because you said those are only type classes. What the hell are type classes?
Yeah. So that's my point. Is that the duality of like when to define methods and when to define extension methods is not only about Scala 3, because in Scala 2 you have the same problem, like when to define defs and when to define type classes and bring the methods that way.
But is there any kind of like formal definition that something is a type class in Scala 2?
In Scala 2.
Because everyone tells those are type classes, but what are type classes?
I mean, for the sake of
There's
this.
formal called type classes in Scala 2, right?
For the sake of this discussion, it's the possibility to bring methods, to call methods that are not defined in a class and are defined elsewhere and brought in using implicits. So this duality of where you can define the methods, like in class or outside the class, it's also about the Scala 2.
Yeah, true. I'm just the question is, why would we like to have one code base?
What if? So there are ways to already like reject the new features in Scala 3. So I don't know. They could. Yeah, you can use, for example, flags to say only accept the Scala 2 syntax.
Kind of improvement, and that's just the way of life.
Okay.
I've been using the original actors, so.
Yeah.
I've been using the original actors, migrating from them to Akka, so I
Oh,
know
wow.
what makes the difference.
Yeah.
I think a good way to get started with Scala 3 is just like you started with Scala, which means start using it as better Java. In case of Scala 3, start using it as better Scala 2, which means like just take your Scala 2 code base and compile it with the Scala 3 compiler, and then gradually migrate as you learn more features and see better ways of doing things, then do things better. If you don't see better ways of doing things and do them the Scala 2 way, I mean, it's also okay.
Yeah, I think those features such as extension methods, they are kind of niche features. Not everybody needs them. Like you can write your entire application without knowing that there is extension methods. So I don't think the number of features is the real problem here. I think it's more that people from the community, they are eager for those kind of niche features, and they talk a lot about them. But also us, like when we write documentation, we are so proud of this new extension method that we write it everywhere. But then it's understood to get for beginners. So maybe we should focus more on more simple style in the documentation, also at conferences and those kind of things. Because in other languages, such as, for instance, C# or even Python, like those are perceived as
But yeah, if you want to try Scala 3, I'd suggest doing the Advent of Code challenges.
Yeah.
Because that's a kind of small way to get into it, because usually you only need sort of 50 lines of code or such to begin. So for example, where would I go? Yeah, so if I go to the code, then I'll just show you day one, because it's day one. Then, this is what Scala 3 code looks like, and you run it just with the Scala CLI tool with 3 lines of code. So yeah, I think using Scala CLI is a good way to get started. Oh no, he goes to
Yeah, I will go. Oh, it's still slow. Yeah, I deployed a new version of ScalaDex yesterday just for this meetup. That's why it's slow.
Yeah, so it's the tool made by Virtus Lab, and it's basically just a single command to compile, run, test, package, publish code without having complex configuration. For example, let's see. Yeah, so you can import libraries using this comment syntax, and then execute code quickly, and you don't need to worry about SBTs, domain-specific languages, or whatever.
And there is a zip to make Scala key the default Scala command, like to replace the current Scala, which is a REPL if you use it. So we hope that for beginners, it will be easier to start with this Scala CLI that is a bit more powerful than just a REPL, but not as complex as a build tool. Yeah.
Okay.
If Scala 2 was being sold as a better Java, like right now with this new syntax, this Scala 3 could be sold as a better Python. I think it's like with typings that actually work.
Yeah. Yeah, I think that's the plan on in the back of the head of Martin. Better Python.
I think a good question is about the difficulty of the adoption, like relearning Scala 3 from Scala 2. Please raise your hands who thinks that it would take a month or more to learn Scala 3 from Scala 2 background. No. Okay. What about a week?
More than a week.
A week.
Okay.
Okay. Yeah.
Where would you go to learn Scala 3?
Where would I go?
Yeah.
Yeah. By the way, if you're unsure about Scala 3 and you have the Scala 2 background, then the migration guide.
Ah, yeah, migration guide.
So if you're in the documentation website, just click Learn, and then we have this migration guide, which basically tells you all the important differences. There's not many, but there's some. And we have some tools to help you migrate, such as the Scala 3 migrate tool, which sort of does all the sort of syntax rewrites that are necessary.
And another point is that in our work on Scala 3, we tried to make the migration effort as painless as possible, and an integral part of that is capability to compile the Scala 2 code base with the Scala 3 compiler with minimal changes. So some of the features that are supported in Scala 2 but will be deprecated in Scala 3, like implicits, they are still supported. And you can gradually enforce disabling them with a flag. But the point is that if you compile your Scala 2 code base, chances are it will compile out of the box. Otherwise, you might need to consult this guide. It's not to say that you need to learn this guide to start compiling your code base using Scala 3 compiler. So my point is just try writing it as Scala 2, and that can be a good start.
Mm-hmm.
Okay, so let's thank guys once again. There's one more thing.
Thank you for having me. Yeah, so I'm Michał Sitko and I'll be talking about Terraform. So I will basically walk through my little thought experiment I did. So I'm an avid Scala developer and I love Scala, and from time to time I need to, as part of my job, I also need to work with infrastructure as a code, and I also like it, but it's also interesting, like cultural clash, because coming from functional programming, you need to interact with all these concepts which are so much ingrained in this bash style stringly typed tools, and even though there is a lot of development, I think it's still persisting. So I think we all are in interesting position here, because we can try to maybe apply all those techniques from FP in some other context. So that's what inspired me to work on this little project, and it's not a finished piece of code. And I doubt it will ever become one, but yeah, it's just a thing I wanted to share. So before infrastructure as a code, if you wanted to, let's say, configure a static website using S3 and I know root 53 and what else, you had to basically go through a list of 12 steps, as you can see, and it's very manual, it's very tedious, takes a lot of time, it's not reproducible. So that was the state of the things some time ago. And with a Terraform, you can define the same thing basically as a code. So it's reusable, you can parameterize it, and you can, you have all the advantages of having it as a code. And of course, Terraform is not the only tool. There are many others. But what's interesting about Terraform is that it embraces the declarative way of defining infrastructure. So you never think in terms of what steps needs to be taken to provision your infrastructure. Instead, you just define what is the end state of the infrastructure you're aiming for. And Terraform is able to inquire for a current state of your infrastructure and come up with an actionable diff that it will be also able to execute. And other interesting thing is that it has a pluggable architecture, so basically whatever cloud provider you use or whatever cloud solution you use, I'm pretty sure you will be covered because it has so many of them. So I really liked Terraform. It's an amazing tool, but there was also one thing I didn't like, and that's the language in which you define your configuration. It's called HCL, and I don't think it was designed as Scala was. I think it just happened basically, and they had to come up with some templating language, and then with various feature requests and what else, they came up with the current state of things. And HCL is very limited. You have no enums, which would be extremely useful, because usually all these cloud providers, every option is basically an enum, because it's usually five possible values, but you always go with just a string, and of course no sum types, so there are a lot of optional fields, and depending on context you need to know somehow which fields are nullable or not in a given context. No tagged IDs, so you can mix your IDs of your resources easily, and valid ranges are not documented. So we can take a look at one of like Terraform definitions. It's a very simple one, just 3 resources, and we have a kinesis stream, for example, and we have a retention period of value 24, but we have no idea. Is it seconds, hours, days? I mean, 24, so probably hours, but anyway, I mean, we as Scala developers, even in type-safe config, you have this option to actually provide 24 hours in your .conf file, and it's well understood across the whole stack. So it's one thing missing here. Then we have S3 bucket, and then we have this ACL. And for example, I can easily mess up those resources, and I can provide Kinesis stream ID as a bucket ID, and nobody will complain. And I can provide here an incorrect value as an ACL, and the same thing. So yeah, it really feels like for a Scala programmer, it's very frustrating because yeah, you basically work with strictly typed language, and yeah, and I know also what struck me here is that it's actually very mission critical code. Yeah, I mean with Terraform you can maybe drop your database, or you can provision a fleet of hundreds of EC2 mega instances or whatever else, and I see just no reason why we should use different criteria for I know measuring the quality of code for infrastructure than we do for our domains. So yeah, so that was what like my initial pain, and yeah, the idea behind Terraform for us is very simple. So you should be able to express your infrastructure as a Scala ADT, and then Terraform for us can take these ADTs and can generate .tf.json file, and from there on, it's where the job of Terraform for us ends. And from there on, we just use a normal Terraform toolchain, so the Terraform standard CLI. Yeah, of course, it's more complicated because let's say that you want to work with AWS, and AWS Terraform, it contains over 900 resources, and for each of these resources, you need to consult docs to know which fields are valid and so on. So for that part, I developed this code generator, which based on provider schema. So each provider also provides a schema, and based on this schema, I can generate Scala code. Then this Scala code can be packaged as jar and distributed, and then the Terraform for us project just has to basically include this jar, and yeah, in the end, it can produce this tf.json. So I can maybe yeah, give you a glimpse of how it looks like. So so this is a huge JSON, like 8 megabytes. It's the JSON provided to you by AWS Terraform provider, and this is the input for code generator, and then yeah, I basically run it for you before because it takes like 20 seconds, and then it produces a lot of Java classes. Yeah, so you can see here that's the code generated by the code generator, and maybe in a different window you can see it's like 900 Scala classes actually being generated, and then in the actual I think it's this one. Yeah, that's the actual Terraform, let's say, project. So here I'm defining the same Kinesis stream and the same S3 bucket, and I can also refer to this bucket from this ACL. So at this point, what we've got, we have at least this Java classes or Scala classes generated, but we still haven't achieved our ADTs because, as you can see, it's a very flat class. It's just a number of fields, and yeah, I mean what's also interesting here is that you can refer to the outputs. So every Terraform resource can also have outputs. Outputs are the data that are not available at the time when you write. It's only available once the resource has been created. So we can also refer to these outputs. And here I have another scheme. So to actually achieve the end goal, then we need this box numbered 3, which lies between this jar generated by the code generator and the project. And basically for box number 3, we need some manual, like human input, yeah, because someone who actually understands the structure of the resources has to define like that. If Kinesis stream is not encrypted, then you cannot provide encryption key, and the other way around. If it's encrypted, you have to provide. So, but that's not encoded in a provider schema, so it has to be actually written by some human. And I didn't have time for this, so actually I spent most of the time working on the code generator, and the other stuff is just minimal amount of code to make it demonstratable or yeah. So here is maybe some maybe it gives you some idea how it can look like. Yeah? So here I'm defining that there is something like encrypted stream, and it has this KMS key ID, and the other is unencrypted, and they both resolve to this this low level, say, resource. So then, I mean, it's still a very basic definition, because I haven't introduced these enums for. Probably it shouldn't be a string, right? Probably it should be some sealed trait hierarchy, and so on and so forth. But that's the idea. And regarding related work, there is a project Terraform -HS, which does exactly the same thing for Haskell. Another interesting thing is DAL Terraform, and actually when I started working on this Terraform for S, actually I think using DAL is even better than Scala, because it feels like an overkill to use Scala to basically generate JSONs, and with DAL, which is like by design a Turing incomplete language that basically just is a facade for a JSON schema or YAML schema, it sounds like a perfect match. So I need to take a closer look at this one. Another is Pulumi. I mean, Pulumi actually is not working that much in direction of capturing the essence of these providers with types, but rather it tries to improve on expressibility, because with Pulumi you write your configuration as using Python. And yeah, so that's it. So thank you very much, and yeah.
We have time for 2 questions, let's say. So, any questions, comments? Well, seems no. Thank you so much for your presentation. It was a very kind surprise to have you on a short notice, but nonetheless, very nice presentation. We'll now have like a short technical break to make it work with Maciej, and we'll be back in 5 minutes, so it's a great time for you to grab another beer.
Okay, thank you very much. Hello everyone, I hope you hear me well. I'm very sorry I can't be there with you in person, but on the train to Warsaw I got COVID. So this talk will be remote, even though I'm just like a few kilometers away. Let me just try to share my screen now. Not this one, this. Okay, this one. Yeah, okay. First of all, this will be a talk about the performance tips in the IntelliJ IDEA and IntelliJ Scala plugin. IDE, like IntelliJ IDEA, is probably one of the most complicated applications that you can have on your laptop. Maybe some 3D graphics tools are more complicated than this, but usually if you have your IntelliJ IDEA on your laptop, that's one of the heavy lifters. In consequence, we, the Scala plugin team in JetBrains, from time to time we receive reports that our product lags in certain situations or it works slowly in general. In some cases we can help. In others, for example, when your code base is big and complicated or when your machine is old, there is not much we can do. Instead, there are some things you can try yourself to improve your IntelliJ IDEA and the Scala plugin experience, like configuration tweaks, good coding practices, and so on. In this talk, we will quickly go through them. But first, I would like to introduce a few terms because we will switch through them from one to another during this talk. First of all, IntelliJ platform is like a foundation for different JetBrains products. In this case, IntelliJ IDEA, but also Android Studio, PyCharm, different IDEs built with the same platform. On this, we have On this, we have IntelliJ IDEA, exactly like the flagship product, which is an IDE mainly for JVM languages. And finally, we have the IntelliJ Scala plugin, which is a plugin. You have to first install IntelliJ IDEA, then go to the JetBrains marketplace, download the plugin, and voila, you have it. All right, so since we have it now sorted out, let's move to the main topic. The main areas in IntelliJ where performance matter the most are when we import a new project, open an existing project, and like the other half of the whole thing is highlights and refactorings. The first part, the importing and opening, is mostly, it can lag because of memory allocation. The other highlights, refactorings, this is logic. This is not really connected to memory allocation, more to your CPU. In both cases, though, we have similar ways to improve performance. We can give IntelliJ IDEA more resources, we can disable expensive features, or we can simply have some good coding practices that, well, I will talk about it in a moment. First of all, though, let's start with resources, but before even that, I would like you to check if you really need to do that. There is the small feature called the memory indicator in IntelliJ. You can enable it by clicking right on the bottom panel of IntelliJ IDEA, and then when that menu pops up, clicking on that memory indicator line here in the menu. The memory indicator will tell you how much memory your IntelliJ IDEA actually uses, and so you will be able to set that memory size in the options accordingly. Please keep in mind that an average laptop nowadays has more than 8 GB of RAM, and this should be more than enough for both performance of your IntelliJ IDEA and for your operating system and other applications. So like in common case with some medium-sized code bases and not too complex logic of your project, everything should be enough. Like those performance tips I'm talking about should be used maybe sparingly in some corner cases. But maybe you just need to increase the memory allocation a bit, and you can do it in IDEA VM options. You can open that from the help menu. And you can choose edit custom VM options and change the XMX setting to a value slightly bigger than what the indicator showed you. So also, like, please note that this is not a straight line. The value of the XMX won't improve the performance anymore over some But in my case, on my laptop, increasing it to 4 GB had some effect, but over it, the additional improvement was negligible. In the case of Scala plugin, we have one more thing we can do. Increasing available memory may also speed up compilation if you decide to compile your app from within IntelliJ IDEA. To do that, go to Preferences, Scala Compiler Server, and under here, Build Compile Server, you can modify those BM options. Moving to the CPU side, this is more important and maybe more tricky part. The most important feature of the Scala plugin probably, and one that can use a lot of CPU, is the set of inspections. An inspection is a piece of logic that well, inspects your code and looking for something specific, some specific problem that your code might have. Some of them are very simple, like a private variable that is never modified and so can be quickly replaced by an immutable value. Others may take a long time to investigate, especially if your code base is big, because the inspection will work for every a declaration, every piece that can be parsed from your code. So first of all, that's not even connected to the performance tips, but if you go to the preferences editor inspections, it would be good if you have time, I don't know, on the weekend, and just look through them and get to know what IntelliJ can give you, like what are the things that actually work on your code while you're working. And you can then think about what is useful to you and what can you do without. Also take note, for example, that if the project is okay, right. So yeah, memory doesn't really affect the speed of inspections. And please note also that the inspections for a different programming language will not be run anyway. So we are talking here only about Scala inspection, although this point has a little asterisk, and I will talk about it later. Now I would like to show you a few inspections just to give you like a general idea how can you how can you think about what is usable and not while you look through them. First is an inspection that checks if this piece of code, something like this, can be replaced by something like this. So we are looking for this value.isInstanceOf, but not all of them. We are only looking for certain situations when this can be changed into a match case without changing the logic. So actually, if you have code that, for example, doesn't use this kind of things, like you have in your rules during the code review that you don't want to see is instance of, you can be then it's pretty safe to just disable this particular inspection, because otherwise it will anyway look through your code and just it will be maybe quicker than if there were instance of, but anyway, like it will use a bit of the CPU cycles. Another thing is, for example, if you have a project that is complex enough to have different types of code, like in case when you have part of the project in Scala 2, part of a project in Scala 3, and in your Scala C options you have this x source dot colon 3, then there is an inspection that will tell you that, okay, you have Scala 2 syntax, but you maybe want to change that syntax to Scala 3. So that looks through your code. It will look only if that Scala C option is enabled. So you don't have to fear it if you are only on Scala 2 or only on Scala 3. But if you are in this intermediate position and that inspection works, then it might be useful, but you might be in a situation when you don't care and you don't want to change the Scala 2 syntax to Scala 3, or maybe you already did that and now that that inspection just runs free and also uses cycles that could be freed instead. So this is only for like an example. That's when you go through the list of inspections, then you can think about this. Like, okay, that inspection is actually not interesting to me. That's something that won't be in my code anyway. One, for example, thing like that could be also this new, probably very useful annotation, target name. I understand that this can be great if you, for example, have a project that is that needs to be compatible with Java, or if you have many overloaded methods where, because we are on JVM, then, for example, if a method has an argument that is list of something, then another another method with the same name that also has an argument that is list of something but a different something, then this will be not possible to overload on JVM, but we can then use the target name annotation to change the name of that method, and then it will work. But for example, in my case, I usually work with end user applications. This is actually not useful at all. So if I would work on Scala 3, then probably I would like it to disable this inspection, because if it is enabled, then for every declaration in my code, for every method, but also for every value, the inspection will go up the hierarchy tree, and it will try to find, okay, if this method is somewhere there declared with the target name, then here the overridden version of it, well, it needs to also check if this is if the method we are talking about is overridden, then that overridden method should have target name as well, which again might be not useful at all and just waste your CPU cycles. Similarly, because like the target name and many other inspections like that are actually working slowly if the code is a bit messy. If for every declaration, for every symbol in your file, we need to go to and look through a lot of code around it, then we then that inspection will work slowly. We'll have to go through a lot of other symbols in the RFD. For example, we have inspections that will tell you if access can be weaker, when weaker means private and stronger means public. So, for example, if we have a public method, then the inspection will go through the code and see if it actually is used somewhere as public, or it can be turned into private. Or we have a declaration, unused declaration inspection, which also looks through the whole to the code to see if the given method, for example, or the given value is not used at all. If it's not used, then it will be highlighted that the declaration is never used. But if we are talking here about public methods, public fields, public objects, it means, and your project is big, that means that the inspection will have to look through a lot of code. And of course, I don't really suggest that you should disable these two, because they are pretty useful. But this leads us to another point in the presentation, which is simply good coding practices. In the Scala plugin, we don't really do anything different from what you would do when you code or when you review code of your teammate. So we go and look for declaration for code that uses your code. We go and look for implicits and see if those implicits are used by your methods. We try to find where are some transformations that are also hidden and not really visible. So if your code is written in a good way, that helps not only you, not only your teammates, it will help your compiler as well. Your compilation times will be shorter, but also it helps your IDE and Scala plugin. For example, you can spend some time to set proper access modifiers to classes, methods, variables. Please don't overuse type inference, even I know it's generally the Scala feature, but too much of it will mean that the IDE needs to spend time to infer those types. Limit the use of implicits. Prefer loose coupling over tight, which means simply that if we have loose coupling, then every declaration has only some considerably small amount of connections to other declarations. If it's tight, that means that for every inspection, we need to go through a lot of connections, a lot of code to check if something should be done, or maybe something is a warning or an error. In large projects, split code into modules and submodules. Don't use split packages. That means, I don't know if this is a common knowledge, but you can have more than one package keyword in a file, and please don't do that. And the last thing, don't use wildcard imports, which pains me to say. I like wildcard imports, but this is again a thing that means that the Scala plugin needs to look through a lot of additional things to figure out, for example, if some implicit is used somewhere in the code. If that implicit is introduced not through wildcard import, I mean, not wildcard import of a whole big package, then that's much simpler for us. And in all things, all those things, all those good coding practices, IntelliJ Scala plugin can help. Because for every inspection, we also provide quick fixes and refactorings. We can help you organize imports. We can help you figure out what is the explicit type of a variable and we can of a given declaration, and we can simply add it to the code. We can, just like those two inspections I just talked about, we can figure out if a given declaration can be private or protected, and we can just let you change it to private or protected with one click. And also we can help you with extracting methods and splitting classes so that the resulting classes will be smaller, which means better encapsulation, which means that the Scala plugin has all the inspections in Scala plugin have less to work on. And now, okay, we can also in the Scala plugin do some things that are not connected to inspection, but will also help with this with the performance. You can go to just a moment, please. You can go to Performance tab in the Properties Language and Framework Scala, look at the controls there, and consider if your product performance might suffer from one of those issues these controls are about. So we can look for implicit parameter search, and this is a variable that controls how far will Scala plugin go in looking for implicits before it gives up. We can, if your product is big enough to have some documentation with code examples, you can disable parsing that documentation. And also you can not inject other programming languages in the documentation section of your code. And you can disable caching compound types. And one thing I also wanted to say about the inspections from other programming languages. In theory, every plugin that you have in IntelliJ IDEA have access to to every file you open. It's just like usually they play nicely, and when you open a Scala file, and then the plugin that is not interested in Scala files will just check that this is not something that that should be that this plugin should work on, and that will be all. But we have some reason to believe that, for example, the Kotlin plugin registers lots of various contributors to various subsystems related to resolution, type inference, other things like that. And those contributors might also be run for Scala files due to various reasons. So that might slow down the Scala projects, even though the Kotlin plugin does not really help us in anything. So similar to how you can go to the inspections and look for those that are not useful to you, you can go through the plugins list and disable those that are not useful to you as well. For example, the Kotlin plugin. Okay, all these hints we talked about so far, they were for some special cases. Usually, if your machine is good enough, and as I mentioned before, an average laptop is already good enough, your IntelliJ performance should be just fine. Only if your project is especially demanding, some of these hints might be of help. But it might be that for some reason you have to use IntelliJ IDEA on an old computer. In such case, you may try a few more things, like more extreme solutions to make your experience a bit better. So you can go to properties, appearance and behavior, appearance, and you can disable anti-aliasing and disable smooth scrolling. That will mean that your fonts will appear less smooth, and when you scroll the contents of your files, that will feel less smooth as well. But both those features have some impact on performance. If that's still not enough, you can open the file menu and click on Power Save Mode. It will turn off a lot of IntelliJ IDEA features, so I suggest you don't do it, or do it only if nothing else helps. You can also install automatic power saver that will automatically turn on and off power save mode. For example, it will turn it on when you go and use another application, and then you go back to IntelliJ, and then the application will be turned, the power save mode will be turned off. But that might be a bit too extreme. So there's something like a middle way, which is you can turn off type power highlighting. In Scala plugin, we have like basically, we can say that we have two types of errors that are highlighted. One is very simple. For example, you have a method where you give only 2 arguments to it, but the method declares that it needs 3 arguments. So that's very simple to check and highlight. But in some other case, you might need to, the Scala plugin might need to check the type of the argument, and only because the type is different than what is declared, then we should highlight it. But especially if the type needs to be inferred, that will take some time, that will take some CPU. So you can disable it here on the bottom menu. You can click on this T icon. Yeah, and last but not least, if you experience low performance, especially in some specific situations, and you can reproduce it, it might suggest that this is actually a problem within the Scala plugin. Please write to us about it, or even better, install the performance testing plugin, capture a performance snapshot, create a ticket in the JetBrains UTrack system, and upload the snapshot there. Your feedback will help us identify problems and solve them, making the Scala plugin more efficient and, well, more enjoyable for all of us. And that's it. Thank you very much. Again, my name is Maciej. I work in the Scala plugin team in JetBrains. Please take a look at our blog, and you can also follow us on Twitter while you still can. There should be some merchandise somewhere around you. Please look around. There are stickers, pin-ups, and some multi-tools from JetBrains. Thank you very much. I can share my slides on Twitter. I can give you the handle later. But yeah, I think that would be a good idea to put it in a blog post as well. I will think about it. Thank you. I don't know much about it. I know that like in the Scala plugin, most of our work goes to the community, so it's freely available. I think mostly we work on those two levels, community and ultimate. Maybe there were some discussions about more, but I can't say. Good idea. I will pass it to the team. Unfortunately, that's very subjective. We can't really say, we can't make like an objective list of the inspections from the most complex to the simplest, because it depends very much on your own product. You can use Scala Profiler and some that performance testing plugin, and you can do it yourself. We have some like more or less groups, like we can say that this group of inspections is more complicated than some simple ones, and we work on improving the performance of the more complex ones, but we can't really, yeah, that's all we can do. Thank you and have a great evening.